obtain general expression for electric field intensity at any point due to short electric dipole. Very IMP question and asked in various examination. So today we are going to learn how to obtain expression for electric field intensity at any point due to short electric dipole. So what is electric dipole? In electric dipole there are the two charges. One is a positive charge and negative charge, and both charges are equal in value. If it is 50 coulomb, then it is also 50 coulomb, but one is a positive, another is a negative. So the two charges, when one is positive 50 coulombs, another is a negative charge minus 50 coulombs, then that arrangement is called electric dipole. We join both the charges by a single straight line. The distance between both the charges, we can take it as a 2L, twice L. That means from center, the distance is L. L plus L equals to 2L. This 2L is nothing but called dipole length. While dealing with the electric dipole, we usually keep the negative charge left side and positive charge right side. Generally we follow this trend, and the direction is from negative charge and towards the positive charge. So the arrow mark points from negative charge to positive charge. This direction is nothing but called direction of electric dipole. Since we are using the arrow mark, therefore the length 2L. Now L can be considered as a vector quantity, and let vector P be the electric dipole moment. Electric dipole moment is given by product of magnitude of one of the charge and the vector 2L. So Q is nothing but magnitude of one of the charge. Both the charges of equal magnitude. So electric dipole moment is given by vector P equals to product of Q and 2L vector. And if you want only magnitude, then the magnitude of electric dipole moment is given by Q multiplied by 2L. Here vector symbol will not come. Let O be the center of dipole. So O is nothing but center of dipole. And consider a point P. Here we have to find out, at the point P we have to find out electric field intensity. And what is this? It is a short electric dipole. What do you understand by short electric dipole? Short electric dipole is nothing but if the two charges are placed such that the distance between two charges is smaller than the wavelength of electromagnetic radiation. So such arrangement of two equal and opposite charges is nothing but called short electric dipole. Now join O and P, and angle between dipole and the line OP is the theta, and call this point A. Other end of the dipole is a point B. Let distance OP equals to R. Therefore the coordinates of point P, polar coordinates of point P becomes R comma theta. Now resolving this dipole moment into two rectangular components, that is along OP and along a direction perpendicular to OP. So this direction. So we are splitting, we are getting components of dipole moment along OP and perpendicular to OP. So component of dipole moment along OP is given by P cos theta, and perpendicular to OP is given by P sin theta. Now extending this diagram along OP, that is DOD, and perpendicular to OP, that is OC. So we got, why we are drawing this diagram? So that we can find out the resultant electric field intensity due to this short dipole. So this is C, and along PD it is electric field intensity E1, and along PC it is electric field intensity E2. And to get the resultant electric field intensity, we need to complete this parallelogram so that we get the diagonal. Let us call this is the diagonal of parallelogram, and complete the parallelogram here. So they are both perpendicular to each other. The resultant electric field intensity is obtained by using this formula, that is under root of E1 square plus E2 square plus 2E1 E2 cos 90 degree. Why 90 degree? Because both electric field intensities are perpendicular to each other. Angle between them is 90 degree. Implies E equals to under root of E1 square plus E2 square, where 2E1 E2 cos 90 gone, because cos 90 equals to 0. 0 multiplied by anything is 0, so that is gone. Now what is E1 value and what is E2? How to obtain E1 and E2? What is E? E nothing but PF in the diagram. Now E1 nothing but electric field intensity, which is nothing but given by 2p cos theta divided by 4 pi epsilon naught r cube. This value is along PD, and E2, that is nothing but p sin theta divided by 4 pi epsilon r cube, and that is nothing but along PC. These are the well-known formulae for electric field intensity. I have just utilized them. So we got expression for E1 and expression for E2. Now we will put these both values in this equation. Therefore E equals to, that is under root of E1 square plus E2 square, that is equals to under root of, what is E1 value? 2p cos theta divided by 4 pi epsilon naught r cube, and what is E2 value? p sin theta divided by 4 pi epsilon naught r cube. Of course, here is a square, here as well as square. Therefore E equals to 4p square cos square theta divided by 4 pi epsilon r cube whole square plus p square sin square theta divided by 4 pi epsilon r cube whole square under root of. So this is equals to 4p square cos square theta. Both denominators are equal, so adding numerators, p square sin square theta divided by 4 pi epsilon r cube whole square, which is equals to 1 upon 4 pi epsilon r cube under root of, here in numerator we can take p square common, So p square we have taken common. We got 4 cos square theta plus sin square theta. Even p square can be taken out of the root. So we get p divided by 4 pi epsilon r cube, and 4 cos square theta can be written as 3 cos square theta plus cos square theta plus sin square theta. The value of cos square theta and sin square theta equals to 1. Therefore, E equals to P divided by 4 pi epsilon naught r cube under root of 3 cos square theta plus 1. So this is required expression for electric field intensity due to short dipole. Therefore, electric field intensity due to short dipole. AB is a short dipole, and at the point P, at a distance r from the center of the dipole, electric field intensity is given by P divided by 4 pi epsilon r cube multiplied by under root of 3 cos square theta plus 1.